Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and we are talking about the casting process, and today we will be talking about the commonly used terms for the casting process. So, as you know, the casting is one of the fastest route to get the desired size and shape just by melting the material and pouring it into the mold, so that after the solidification we can get the desired casting. So, but here the mold is very important component, because the cavity mold is nothing just a cavity wherein molten metal is filled in to get the desired component after the solidification of the molten metal. But for the preparation of the mold, and there are number of structural elements and number of components which are used in the molding and casting process. So, we will try to familiarize with the commonly used terms related with the casting. So, normally the sand mold casting process is one of the most commonly used process for like say for job shops or for like a small volume production, and especially like say the complicated shape products are for automotive industry are extremely are commonly produced using the sand mold casting process. So, as far as the molding is concerned, the casting process is grouped under the two broad headings. One is expandable mold casting, and another is permanent mold casting. So, in case of the expandable mold casting, these are prepared and used for once only, means one casting is made, then these need to be destroyed, and again another mold is to be prepared for making the another casting. So, sand mold casting is one of the expandable mold casting method, wherein the sand is used for making the mold, and every time sand mold is required to be prepared for making the casting, and these are broken once the casting is ready. After the solidification, the mold is broken, while in case of the permanent mold casting, these can be used repeatedly. Repeated use is allowed, and the number of castings can be made using the permanent mold castings, and these numbers can be very high, maybe like say 100 to 10,000 or even 1 lakh number of the castings. So, depending upon the volume of the production, the metallic molds or other types of the molds are or permanent molds are prepared. Permanent molds are mostly made of the metals. So, there are different processes which use the metallic mold, and among these is one of the commonly known as the die casting, or this is also known as the permanent mold casting, and others like hot die. These are the variants of the die casting. In die casting, normally the solidification occurs under the gravitational force condition, and here in the hot die casting and cold die casting processes, the external pressure is applied. So, under the influence of the external pressure, the feeding as well as the solidification of the molten metal is achieved. So, the permanent mold casting is justified for large volume production as well as where good quality or good quality surface finish as well as the close dimensional tolerance is required, while for other cases where the volume of the production to be done is limited and that you can see the final size and shape can be realized using subsequent machining processes, then sand mold casting is more economically justified. So, how the sand mold is prepared and what are the common terms related with the sand mold casting, that is what we will try to see. So, it basically uses the metallic flasks. It uses the metallic flasks for holding the sand. So, there are 3 types of the flasks depending upon the geometry or the size of the castings to be made or the mold to be made. We can use the flask, there is a cup and there is a cheek and the drag. So, like say these are the flasks are nothing, just they are like rectangular shaped thin walled boxes which are open from both the sides. So, you can say in the top view it will look like this and in front view it will look like this. So, the flasks, these are the thin walled steel flasks where one side there may be joint also. Normally these have like the arrangement for alignment of the flasks like a pin and the hole kind of thing we can see. So, these are used for the 2 purposes, one is alignment and another is holding the flasks together. So, when 2 or more number of the flasks are used, these flasks are kept one over other and they need to be aligned properly and held properly, so that the shape of the casting, shape of the mold can be maintained, and for this purpose these slots and the holes are made so that the pin can be inserted in order to make them properly aligned and held in line. So, like say the flask, one flask in front of you, if you see the flask like this, one flask, there is another flask and third flask. If you are using 3 flasks, then the one flask which is used at the top is called the cope and the one which is used at the bottom is called drag, and the one which is kept at the middle is termed as cheek. So, however, it is common to use the 2 flasks which are termed as cope and drag, but for the large and the complicated shape castings, even third flask termed as cheek is also used. So, if we see here, like say this is the flask, the top flask, and where these 2 flasks meet each other, that forms the parting line. So, here let us say these flasks are actually full of the sand like this, and then and these 2 flasks both will be meeting. So, the line along which the 2 flasks meet is called the parting line. This is cope and this is drag. So, what we try to do here, we will be making the different parts and the features which are normally used in the molding. These are achieved through the packing of the various components during the sand molding. So, here first of all we will try to prepare the pouring basin. So, like this is open and conical. So, this is pouring basin. We try to feed the molten metal with the help of the ladle, like say this is furnace. So, molten metal is tapped from the furnace into the ladle, and this ladle is used to transport the molten metal to the mold. So, the molten metal from the ladle is poured into the pouring basin. So, molten metal will be coming here, and then pouring basin is designed in such a way that it filters the impurities. So, pouring basin is designed in such a way that the impurities are filtered. So, like the oxides, slag, dross, etc. is filtered, and thereafter the molten metal will be flowing into the sprue. So, sprue, after the pouring basin, the molten metal goes into the sprue, and then it changes its direction of the flow at the sprue. So, this is the sprue slightly reducing in cross section. In the sprue, molten metal will be flowing at a higher and higher velocity as it moves down, and here at the sprue, at the bottom of the sprue we have sprue base. So, here there will be change in direction of the molten metal, and then after reaching to the sprue base, it flows into the runner. So, this reducing cross sectional member is sprue. This is made of the reducing cross sectional, so that cross sectional area, so that air aspiration is reduced, and it is always full of the molten metal. So, the air is not sucked into the molten metal, and so it remains clean, and the gases are not the gases do not get mixed up with the molten metal, and after reaching to the sprue base, the molten metal starts flowing into the runner. A runner is designed in such a way that it also helps to prevent the entry of the light metals like oxides, impurities, and slag, dross, and it is stopped at the top level, and entry of the molten metal takes place through this region. So, this region where from molten metal enters into the mold is termed as this cavity where from molten metal enters into the mold is called ingate. And this cavity, according to the shape of the casting is termed as mold. To take care of the shrinkage of the molten metal in course of the liquid to the solid state transformation, risers arrangement for the riser is made. So, riser next to the mold is placed in such a way that it can feed the molten metal to the cavity as per the requirement. So, whenever we feed the molten metal to the mold, so after filling the mold, after filling of the molten metal into the mold, molten metal enters into the riser. So, this riser supplies the molten metal at the time when shrinkage of the metal on transformation from the liquid state to the solid state takes place. So, basically the role of the riser is to supply the liquid metal to the mold when this shrinkage due to the solid liquid to solid state transformation occurs. And if any internal cavity is to be made, then that modification is also made here. Like say if the internal cavity of a particular shape is needed here, then we put one core. So, this is the core. So, this is the region where molten metal will not be able to enter due to the presence of core. So, this additional feature we can call core is used for generating the internal holes or any other spatial geometry. So, for this purpose the core is used, and core is kept in the sand mold. So, we can say that portion is called core seat, where the core will be kept in the mold, and this is the riser. So, these are the various terms. This is the sprue base, ingate, pouring basin. Pouring basin will be doing filtration or cleaning of the liquid metal, cup, drag, parting line, and in order to hold the cup and drag with each other, and normally the pins are used, so that the pins will be helping them to keep aligned as well as hold them together, so that the separation of the mold due to the metallostatic pressure after the feeding of the liquid metal to the mold is avoided. So, the molds are like cup and drag. The flasks are aligned so that the cavity maintains its shape, as well as the separation of the flasks at the parting line is avoided under the metallostatic pressure of the liquid metal due to the holding of the flasks with the help of the lock pins or nut and bolt. So, that is the kind of arrangement which is used. Normally a very detachable locking arrangement is used in the flasks in order to avoid these separation of the flasks. So, let me see if something is left here. So, in addition to this some more words and the common terms are used related with the casting, like one is chills. Chills are nothing, just these are the metallic pieces kept in the mold. Like say the chills we may place in such a way, like this is the chill which has been placed in the mold. So, purpose of this is, these are the metallic pieces. So, purpose is to increase the cooling rate selectively, at a specific location selectively. Purpose of this selectively. So, purpose of this is to have the cooling rate is increased selectively at a specific location, so as to have desired temperature gradient. And the purpose of having the desired temperature gradient is to ensure that the directional solidification is achieved. So, this is primarily purpose of the purpose of using the chills. So, chills are the metallic pieces and they will be placed suitably in such a way that the directional solidification is achieved. These do not form the part of the casting. And then other common term which is used is the chaplet. chaplet. A chaplet is used, chaplet is a kind of the metallic piece which is used to support the core in the cavity. So, like say this is the cavity, this is the mold, and we want to support the core inside the mold. So, here seat is limited, and we know that if the size, if overhang is this much, then the mold will have tendency to settle down. So, or to get fractured. So, in order to provide suitable support, the metallic pieces like this are kept in the mold, so that they can provide the support and the position of the mold is not disturbed when the pouring of the molten metal is done into the casting. So, basically the chaplets provide support to the core. So that it does not break, or its position is not disturbed in the casting, so that we can have the internal cavities at the desired location. It is expected that when the molten metal is poured, so the surface of the chaplet will be under the influence of the heat of the molten metal, the surface of the chaplet will be melted down and it will form the part of the casting. So, the size of the chaplet becomes important, because if it is too heavy, then it will extract lot of heat and the melting of the surface of the chaplet may not be facilitated, and if it is too thin, then the chaplet may melt completely as soon as the molten metal is poured into the casting, and in that case it may not be able to provide the support to the core, as the so that required function is not achieved. So these are the common terms which are used related with the casting, and we will try to see this using the PPT to have the more clarity in terms of the diagram which is used. So, like say here these are the two flasks, this is the cope upper one and this is the drag lower one, and the two flasks are aligned with the help of these two like pins, one side, another side. So, these two pins will be keeping them in particular position aligned, as well as these can be tightened in order to avoid the separation of the flasks. This is the pouring basin. Here in this kind of design, there will not be any kind of the filtration of the impurities, but the kind of design which I had made, in that case the filtration is also facilitated. So, we can make the pouring basin in such a way that the impurities can be separated, impurities like dross or oxides or inclusions, etc. Impurities can be filtered out, and this is the sprue and this is the sprue base and the parting line where the two are getting two are meeting, and this is the runner through which the molten metal flowing after passing through the sprue base. And here in this design they have made riser here itself. This will be filled in after the mold cavity, that is this one is filled. So, mold cavity, this entire zone is the mold cavity, here this is the ingate, and the core is provided in order to make the internal hole in this casting, and here the seat which is provided for positioning the core is the core seat or the core print. So, this is made, so you can say the internal holes are made with the help of the cores. So, this entire system, right from the pouring basin to the sprue base, runner and the mold cavity, riser, etc., all these form the part of the gating system, and this is to be designed properly, so that the molten metal can be fed into the casting in the minimum possible time, and the suitable directional solidification is also achieved, so that the casting is free from the defect and like the issues related with the shrinkage and others can be taken care of effectively. So, now we will see other terms which are related with this. Here they are like, say, the pattern. Pattern, although I have not talked about the pattern so far. So, pattern is like the mold cavity is the cavity which is having the shape of the casting to be made. Say this is the cavity and the shape of the casting to be made is almost the same type like this. So, if this component is to be made, then the cavity of this kind is to be prepared. So, and this will be filled in the molten metal. So, in order to prepare this cavity of the sand mold, then we need to first of all make a pattern. Pattern is nothing, just a model or replica of the product or casting to be made. So, but the shape may be same, but it is different in terms of the dimensions. And what these what are the factors which lead to have the difference in the dimensions, about that we will talk now. So, this pattern, actually the first thing which is done for in the casting process, first of all we prepare the pattern, and then using pattern we make the mold, and once the mold is ready, we go for melting of the material, and once the material is melted, the pouring of the molten metal is done into the mold. Thereafter solidification will be taking place, and after the solidification the casting is taken out, and then cleaning is done like fettling, tumbling, sandblasting, etc. And then we inspect the casting whether it required casting with the required features and dimensions, and the free from any defect has been produced or not. So, the preparation of the pattern is the first step in the casting, and so the pattern is used for making the mold. So, the patterns pattern actually differs in terms of the dimensions from the casting to be made due to the two regions. It's a model having the same geometrical features, but different in dimensions. So, the reasons for the difference in dimensions is that we need to provide certain allowances, so that it is so that the required subsequent operations can be carried out on the casting which has been prepared and which has been made. So, in addition to the allowances, provision of the allowances, we try to make the core prints also in the pattern. So, pattern will have the different size and shape due to the core print. Core print feature is incorporated in the pattern itself. Allowances, because of the allowances, it's the dimensions become different, and some the fine details are not incorporated in the pattern, because if the details are very fine, like half mm thin section of the greater length is to be produced, then probably it will be better to machine it out, or some slot of the half mm thickness is to be made of the greater length of the high. So, means high aspect ratio slot is to be made, then this will be omitted from the pattern, and better it will be made using the machining process. So, after the casting it will be machined out. So, fine details are not incorporated because these otherwise will be leading to the lack of filling or the defective casting. So, we something which cannot be produced effectively efficiently using the casting route means some of the geometrical features, if they cannot be made using the casting route in the casting or in the component, then they will be produced by the machining. So, these details are also omitted or these are not incorporated in the pattern. So, basically it is a model of the casting with these differences. We have the allowances, we make the arrangement for the core pins, so that the seat for the core can be made, and then it will also have the means the finer details related with the products will also not be incorporated in the pattern. What we can use for making the pattern, that is another important thing, because this is the first step for making the mold is to prepare the pattern first. So, we need to talk about the materials for pattern. What material can be used for making the pattern? So, depending upon there are certain factors which will govern the selection of the material, and these factors include the size of the casting. Like for very large size casting, we prefer to go for the wood only, for wood for very large size casting, because metallic patterns will not be easy to handle for preparing the mold. So, we prefer for the wood. Otherwise, like say the surface finish, if some of the components to be used in as cast condition, then better to consider the surface finish. So, surface finish is another component here, like say if the good finish is desired, then metallic pattern is preferred or the plastics are used. Otherwise, for reasonably good finish, we prefer the wood. And then dimensional accuracy, which is desired. So, metals and plastics offer good dimensional accuracy than the wood. So, these you can say in the order of the preference for the finish as well as the dimensional accuracy of the material to be used. Then there are certain additional features like the conditions in which it is to be used, like the moisture. If the environment where patterns are to be used is very moist, then wood is not preferred. It is more preferred to use the metal and the plastic mold over the wood patterns. So, considering these points in mind, these are the factors which are normally considered for the purpose of the selection of the pattern material. Now, we will talk about all three materials which are used for making the pattern and when they are preferred. So, if we talk of the wood, wood is very easily available, it is very low cost, its low cost, availability is good, and shaping is easy, any shape can be, shaping is easy, any shape can be made. So, it is, and because of these features it is good for the low volume production, means when few castings are to be made, then the wooden pattern can be used. But there are issues like the woods absorb the moisture. So, moisture absorption leads to the change in dimensions. So, once there is a change in dimension, then it will be leading to the change in size of the mold cavity, and which will lead to the having the dimensions of the casting which are not desired. So, change in dimensions, or even due to the wrappage, the shape is also modified, and due to the rubbing with the sand, the wearing, rubbing with the sand leads to the wear of the pattern. So, that will also be leading to the loss of the dimensions of the pattern. So, these are the undesirable features. So, we can say that the stability in terms of the dimensions and the shape of the wood pattern is poor. Also, the surface finish and the dimensional accuracy which is achieved in the casting is poor in case of the patterns which are made of the wood. So, still it is good to make the patterns of the wood for the low volume production, for the low cost production, but when the volume of the production is high, then really metallic mold patterns are preferred. So, among the metals, these are like, say, we can use cast iron, we can use steel, we can use brass for this purpose, and these are good for the high volume production. These are good for the high volume production, also results in the good surface finish, and very close control over dimensions. So, these are the very good sides, and the stability of shape, size, and there is no moisture absorption, the wear resistance is also high. So, these are not the problematic, the problem is handling. So, because of high density, handling and handling is since these are heavy, so handling will be difficult. It will be leading to the more fatigue to the operators or the person who is doing the molding. On the other hand, if we consider the plastics are good in that way, like the dimensions of the pattern, shape, both having good stability. So, this is very good side. These are also having low weight, so light in weight, which was the negative point of the metallic pattern, as well as no moisture absorption problem, no moisture problem, dimensional stability is good, surface finish is good. So, the surface finish achieved, surface finish of the mold surfaces produced by the plastic patterns is also good. So, these are used for the high volume production, So, here, these are the materials which are used for making the pattern. So, here now I will conclude this presentation. In this presentation, I have talked about the commonly used terms in the casting process, and also the patterns, what is the pattern and what are the different materials which are used for making the pattern, and how to select the pattern for the different conditions like the dimensional requirement, surface finish requirement, and the working conditions, the volume of the production which is required. So, all these factors need to be considered while selecting the material for the pattern. If the material is selected properly, then probably we will be able to have the castings of the desired quality and characteristics, that too economically. Thank you for your attention.